Hello all, welcome to the online video tutorials on computer networks. Myself, Akshat Monnapake, Assistant Professor, Department of Electronics and Communication Engineering, Sai Vidya Institute of Technology, Bangalore. The course name is Computer Networks 18EC 71. Let us start with the introduction for Module 1. In this video lecture, we will be discussing about the networks, the network criteria, and the physical structures. Networks. A network is an interconnection of a set of devices capable of communication. A device can be a host, such as a large computer, desktop, laptop, workstation, cellular phone, or a security system. A device can also be a connecting device such as a router which connects the network to another network, a switch which connects two devices together, a modem which is also called as a modulator and demodulator which changes the form of data, and so on. These devices in a network are connected using wired or wireless transmission media such as a cable or air. Now let us discuss about the network criteria. There are three in total. The first one is the performance. A performance can be measured in many ways, including the transit time and the response time. The transit time is the amount of time required for a message to travel from one device to another, whereas the response time is the elapsed time between the inquiry and the response. The performance of a network depends on the number of factors, including the number of users using that particular network, the type of transmission medium being used, the capabilities of the connected hardware, as well as the efficiency of the software which is inbuilt. Performance is often evaluated by two networking matrices, which is the throughput and the delay. We often need more throughput and less delay. If we try to send more data to a network, we may increase the throughput, but we increase the delay because of traffic congestion in that particular network. The second network criteria we will be discussing is the reliability. The network reliability is often measured by the frequency of failure, the time it takes a link to recover from its failure, and the network robustness in a catastrophe. The third one and the last one is the security criteria. So network security issues include protecting data from unauthorized access, protecting data from damage and development, and implementing policies and procedure for recovery from breaches and data losses. Let us now discuss about physical structures, under which the first one is the type of connection. A network is two or more devices connected through links. A link is a connection pathway that transfers data from one device to another. There are two possible types of communications. The first one is point-to-point connection. A point-to-point connection provides a dedicated link between two devices. The entire capacity of the link is reserved for transmission between these two devices. Most point-to-point connection use an actual length of a wire or a cable to connect the two ends, but other options such as microwave and satellite links are also possible. An example if we take for this, when we change television channels by infrared remote control, we are establishing a point-to-point connection between the remote control and the television's control system. The second type of connection is the multi-point connection. A multi-point connection or a multi-drop is one which more than two specific devices share a single link. In multi-point environment, the capacity of the channel is shared either spatially or temporarily. If several devices can use the link simultaneously, it is a spatially shared connection, whereas if users must take turns, then it is a time shared connection. Let us discuss the second topic under physical structures, that is the physical topologies. The term physical topologies refers to the way in which a network is laid out physically. So two or more devices connected to a link or two or more links form a topology. The topology of a network is the geometrical representation of the relationship of all the links and linking devices to one another. There are four basic topologies possible. Let us discuss one after the other. The first one is the mesh topology. We will be discussing about this mesh topology as well as the advantages and disadvantages of this particular topology. So as the figure represents, in a mesh topology, every device has a dedicated point-to-point link to every other device. That the link carries the traffic only between the two devices it connects. To find the number of physical links in a fully connected mesh network with n nodes, each node must be connected to every other node. That is, if we take physically, node 1 must be connected to n-1 nodes, node 2 must also be connected to n-1 nodes, and finally the node n or the nth node must also be connected to the rest of the n-1 nodes. So we need n into n-1 physical links. If each physical link allows communication in both directions, that is the duplex mode, we can divide the number of links by 2. In a mesh topology, we need n into n-1 divided by 2 duplex mode links. To accommodate that many links, every device on the network must have n-1 input-output ports to be connected to the other n-1 stations. So what is the advantage of this particular mesh topology? The use of dedicated links guarantees that each connection can carry its own data load, thus simultaneously eliminating the traffic problems that can occur when links must be shared by multiple devices. The mesh topology is robust. If one link becomes unusable, it does not incapacitate the entire system. There are advantages of privacy and security. When every message travels along a dedicated link, only the intended recipient sees it. Physical boundaries prevent other users from gaining access to these messages. Point-to-point links make fault identification and fault isolation easy. Traffic can be routed to avoid links with suspected problems. Then what are the disadvantages of mesh topology? The main disadvantage of the mesh are related to the amount of cabling and the number of input-output ports required. Every device must be connected to every other device, so installation and reconnections are difficult. The sheer bulk of wiring can be greater than the available space. The hardware required to connect each link can be prohibitively expensive. So mesh topologies is used as a backbone connecting the main computers of a hybrid network that can include several other topologies. Example of mesh topology. Mesh topologies are used in connections of telephone regional offices in which each regional office needs to be connected to every other regional office. The second physical topology is the star topology. A star topology is less expensive compared to the mesh. Each device needs only one link and one input-output port to connect it to any number of others. It is easy to install and configure. Less cabling needs to be housed, and additions, moves, deletions involve only one connection, that is between that device and the hub. The disadvantage of star topology is the dependency of the whole topology on a single point, that is the hub, which is located at the center of the other devices. If hub goes down, the whole system is dead. Although a star requires far less cables than a mesh, each node must be linked to a central hub. Often more cabling is required in star than in some of the other topologies. Example of star topology is used in local area networks, normally called as LANs. The next physical topology is the bus topology. The bus topology has multi-point connection. One long cable acts as a backbone to link all the devices in a network. Nodes are connected to the bus cable by drop lines and taps. Now a drop line is a connection running between the device and the main cable. A tap is a connector that either splices into the main cable or punctures the sheeting to create a contact with the metallic core. Signal travels along the backbone. Some of its energy is transformed into heat. Thus, it becomes weaker and weaker as it travels further. Thus, there is a limit on the number of taps a bus can support and on the distance between these taps. The advantage of bus topology includes ease of installation. Backbone cable can be laid along the most efficient path, then connected to the nodes by drop lines of various lengths. Bus use less cabling than the mesh and star topologies. Now the disadvantages include difficult reconnection and fault isolation. Bus is usually designed to be optimally efficient at installation. Thus, it is difficult to add new device. Signal reflection at the taps can cause degradation in quality. A fault or a break in the bus cable stops all transmission even between the devices on the same side of the problem. The damaged area reflects signals back in the direction of origin, creating noise on both the directions. The last physical topology we will be discussing is the ring topology. In ring topology, each device has a dedicated point-to-point connection with only the two devices on either sides of it. A signal is passed along the ring in one direction from device to device until it reaches the destination. Each device in a ring incorporates a repeater. So when a device receives a signal intended for another device, its repeater will regenerate the bits and passes them along. A ring is easy to install and reconfigure. Each device is linked to only its immediate neighbor. To add or delete a new device requires changing only two connections. The fault isolation is simplified. In a ring, a signal is circulating at all times. So if one device does not receive a signal within a specified period, it can issue an alarm, and the alarm alerts the network operator to the problem and its location. Unidirectional traffic is a disadvantage. In a simple ring, break in the ring can disable the entire network. This weakness can be solved by using a dual ring or a switch capable of closing off the break. Thank you for watching this video tutorial on communication networks.